Hello guys, we are back with a new question and the question is length of longest subarray with at most k frequency. So what's question? In this question we are given an array nums and an integer k. Also it stated that frequency of an element x is the number of times it occurs in an array. Like here the frequency of 1 is 1, 2 and 3. Frequency of 2 is 1, 2 and 3, like this. Also it's given that an array is good if the frequency of each element of that array is less than or equal to k. Otherwise, like if k is 2 and frequency of 2 is 3, then this array is not good. Okay, so our task is to find the length of longest good subarray of nums. Also, what is subarray? A subarray is a contiguous non-empty subsequence of elements within an array. So, what is subarray? Uh, Subarray is a collection of elements of this array which are contiguous, like 1, 2, 3 or 1, 2, 3, 1, 2. Okay, it cannot be like 1 from here, then 2 we are taking from here, and then 2 again from here. It is not subarray, it's subsequent. So subarray is a collection of some elements which are contiguous in that array. Okay, so how we will solve this? So basically we have three approach we are going to do for this question. First is brute force and its complexity would be O of n cube. Second one is better than brute force and its complexity will be O of n square. And third one will be optimal approach and the complexity will be like time complexity will be O of n. So I will explain all three approaches one by one. So let's see. Let's take this array. How to increase size of this? Let's write down 1, 2, 3, 1, 2, 3, 1 and 2. So what's brute force? Like what we will think after seeing this question, the basic approach, it may have the worst complexity, but what's the basic approach? What we can do is we can find all the subarrays and then take out frequency of all elements in that subarray and check whether it is good or not. Like by applying 2 or 3 for loops, we will find all the subarrays, like first one, then 1 2, then 1 2 3, then 1 2 3 1, then 1 2 3 1 2, like this all. After that, in second iteration, 2 2 3 2 3 1, 2 3 1 2, like all of these. In third iteration, 3 3 1 3 2, 3 1 2 3 1 2 3 and all. So for each of this element we will be iterating loop one more time to find all the subarrays. Okay, so what we will do is we will find all the subarrays and then check whether it is good or bad. So how we will do this? We will take a for loop, and for first iteration we will run it from this element to this element, like I equal 0 to n. And then for each of this I, what we will do is we will take like what we were doing, 1 2 1 2 3 1 2 3 1. For each of this I, we are again iterating till last. Okay, so till from I to n, like here j equal I to n. Like here, if I is this, then j will be first this, then 1 2, then 1 2 3 1 2 3 1 2, like this. Okay, and after this what we will do is we will take this subarray and then count the frequency of each of the element, and checking whether it is good or not. Okay, so how we will do this is, we will take one more for loop to check which all elements are coming, and I will run this for loop from k equal I to j. Like I to j, we will find all the elements. Like in this loop we are getting all that subarray, all the elements of that subarray, and after this what we will do is, we will take a here we will take a map, and then in this loop we will iterate and mark the frequencies of each element in this map, and after that we can check if frequency of any of the element goes beyond k, then it is not our good subarray, and we will break. Okay, similarly we will do it multiple times, and our complexity will be O of n cube. This is brute force, and it is the first time complexity for this kind of question. So how we will better this n cube to n square? So now we will see that how we will do is, like what we are seeing here, like we are going from 1 to 2, then when after this subarray 1 to 2, we are going to subarray 1 to 3, and what we are doing is, from 1 to 2 till 1 to 3 we are making one more map, and again adding frequencies, like 1 is coming one time, 2 is coming to one time, 3 is coming one time. But what we can also do is, like we are going from 1 to 2, 1 to 3, so we just need to do is that we can add frequency of 3 in that map only, instead of making different map and iterating whole of the loop again, we can just adjust in this map only. Okay, so if we will do this, we there is no need of this loop, we can eliminate this, and just in our map what we will make, which map we will make here, we can add like mp of this element nums of j plus plus. We can do this and then count if any frequency goes beyond k, then we will break, otherwise we will go on. And how to count the longest subarray, like we can take initial answer as 1, then our answer will be maximum of ans or j minus I plus 1. It will be the length of our current subarray. Okay, but this is also n square complexity, we have to optimize it more, and our complexity for the optimal solution will be O of n. So now we will see how to solve using optimal approach. So let's erase this. So basically what we will do in this optimal approach is, we will do it by using the concept of sliding window. So here uh, what fears just a second. So in this question what we can see is, we have to find the subarray. Like subarray can be this or this, but it is confirmed it will be contiguous elements collection. Okay, so like this. So what we can do is, we can take two pointers start and end, then iterate it using sliding window concept, and then solve it. Just watch this video, I am telling how to do this. So see, so here in this approach what we will do is, we will make a window of small size this one. Okay, then we will increase this window size, and then shrink from here this left side if we find that our frequencies goes beyond k. If not going beyond k, we can increase our this window size, we can increase until we reach greater than k. Okay, let me explain it more clearly. So for example, we are taking our window size of 1. So our answer is 1. Okay, so what we can do is we can increase this window size from 1 to 2. We can see we have to find the longest window size. Okay, so we are increasing it from 1 to 2 and checking if it is accepting our condition or not. Like here our frequency will be 1 for 1, and for 2 also frequency will be 1, so it's okay. So here our answer size, so our window size is 2 and answer is 2. So let's check, can we increase it more? So what we will do is we will make it 1 to 3, like window size will increase by 1 more. Here frequency of 3 is also increased by 1. Okay, so our answer will be 3. So let's again, like here k was 2 now, so we have to find the longest. So we will again increase our window size like this. So frequency of 1 is increased by 1, so let's increase this by 1, so it will become 2, and our answer will be 4, like because the longest size is 4. Now we will check whether we can make it more larger or not. So increasing our window side from right side, if it will add one more 2, and frequency will be 2. And we will check again, can we increase it? Yes, we can increase. So 1 3 will also be added, so frequency of 3 is also 2, again increasing 1. Now frequency of 1 is 3, which is not acceptable as k is 2. So what we will do is we will shrink our window size from this side until we can find this frequency of 1 become 2 or less than 2. So what we will do is we will shrink this window size, like it was now from here to here, so we will remove this one and our window size will be this. So our frequency of 1 will be 2 and our answer will be like here 3, but max is 4, so we will not update our answer. Now again we will move forward and our 2 will be, frequency of 2 will be 3, and it is also not acceptable, so we will decrease our window size from left hand side. So here this will be our window size, and 2 will be removed, so frequency of 2 is 2, but again 1 2 3 4 5 6, so our answer will be of size 6. Okay, so using this approach we can find it using the optimal time complexity of O of n. Okay, and our answer will be 6. So let me show you code for this. Here I took two pointers S0 and E0, and our initial answer is 1, as we know if there is an array, so at least there will be subarray of smallest size, that is 1. And we took one map where we will store frequencies. Then I am iterating from when e is less than n, like this pointer is less than like end point. Okay, I will, in my map I will change the frequency of nums of e, like this number, like I got to this number 2, so I will change the frequency of 2. So mp of nums is 2, frequency is added, like initially let's suppose it was 5, so it will be increased by 1. So but if there is, like by increasing that frequency by 1, if it becomes greater than k, then what we will do is we will shrink our window size from left hand side and decrease its frequency and increasing our start point. Okay, and for answers we will check our answer will be max of ans, and our subarray size currently, which currently our window size, like e minus s plus 1, and increasing e at n when e will be less than n, e will be equal to n minus 1, our answer will come and we will return it. Let's see. So it's submitted. I hope you got this question, all three approaches, brute force, better and optimal. If you like it, do subscribe our channel and like this video. Thank you.